All right, so let's go ahead and do our final example. This example says the following. We're going to take the spring and mass system from, again, the first example we did tonight. From the first example, sorry. Okay, and this time let's attach a damper to it that will exert a force of 17 pounds when the velocity is 2 feet per second. Okay, and so just as before with everything that was given, we're being asked to find the displacement okay, find the displacement at any time t, which is also known as u of t. Okay, so let's talk about the differences here. So the only difference between this example and the previous one we just did is actually the damping force. That's it. So let's find the damping coefficient. And so let me go ahead and remind you that the critical damping coefficient, which is given by gamma CR, is still going to be equal to 6. Okay, I want you guys to keep that in mind. This value that we found before is going to be exactly the same. All right, so for this problem though, 17 is the force due to damping, and this is going to equal gamma times 2. Okay, so this implies that gamma equals 17 over 2, which then equals 8.5. And you can see this is bigger than 6, or gamma CR. All right. So it looks like we've got overdamping this time around. So we should expect to get 2 real distinct roots from the characteristic equation, and they should both be negative. And so for the IVP, we end up with the following result. It'll be 1/2 u double prime plus 17 over 2, which is gamma, u prime, plus 18 times u, which all equals 0. And for our initial conditions, we have u of 0 is equal to negative 1 over 2. Okay, and u prime of 0 is equal to 1. Okay, so this one's a little messier than the previous example, so we'll do a couple of steps in leaving it to you to fill in some of these blanks. The roots of the characteristic equation are given by the following. It's going to be root 1, 2, which is going to equal negative 17 plus or minus the square root of 145. Okay, all divided by 2. And this is going to equal negative 2.4792, and another root, which is negative 14.5208. Okay, so we have those two roots. So in this case, it will be easier to just convert the decimals and go that route as we did before. But note that as we predicted, we got two real, distinct, and negative roots. Okay? So now the general and actual solution for this example can be given by the following displacement equation. It'll be u of t equals c1 e to the negative 2.4792 t, okay, plus c2 e to the minus 14.5208 t. Okay, so just our two roots. And so u of t, by plugging in our two constants, will then become negative 0.5198 e minus 2.4792 t, okay, plus 0.0199 e to the minus 14.5208 t. Okay, and then we can sketch this example as before. So here's 3 seconds, here's 2 seconds, here's 1 second, and here's 0.25, which is negative, and 0.5 down here. And just as before, we're going to have another curve that comes up, but it's going to be a bit more wider, a bit more wide before it approaches a termination or an asymptote here along the time axis. Okay. Okay, well that's it for tonight, but let me give you guys a little bit of a sneak peek of what's coming next. So next week we're going to talk about undamped forced vibrations. Okay. And then we're going to talk about forced damped vibrations. So those are the last two cases we need to cover for next week. And then we're going to move into Laplace transformations. And then finally, get to the point where we can begin to combine linear algebra directly with differential equations so we can solve systems that are much larger and for multiple sets of differential equations. Okay. Well, thank you guys for coming through with all the lectures that have been given online for this week. Please feel free to come to office hours. I'd highly encourage you if you have any questions about any of the content that was discussed this week or any of the homework problems. I am in office hours every day, Monday through Friday, 4:10 to 5:20. You can use WebEx, create a free user account through Cal Baptist, and then just log in and then ping me and ask me any questions, and in real time I will answer those questions for you. If you prefer, you could just write out your questions by email and I will get back to you as soon as possible by email as well. Okay? Well, then that's it for us tonight. You guys have a great weekend, and I'll see you next week.